Hello everyone, welcome to my channel. Let's learn computer science. Hello everyone, welcome back to another video. In this video, we are going to study about computer memory. Syllabus reference, you'll understand RAM, ROM, SRAM, DRAM, PROM, EPROM, and EEPROM. These concepts are very important for both examinations and understanding how a computer actually works. So let's begin. Before discussing RAM and ROM, let's understand where they fit inside a computer system. A computer, it has different levels of memory. If you look at the top, there is primary memory, which is further divided into, RAM and ROM. RAM is further divided into SRAM, DRAM, which is static and dynamic RAM. And ROM is further divided into PROM, EPROM, EEPROM. CPU accesses primary memory much faster than secondary storage devices such as hard disks and SSDs. So, first of all, let's understand what is RAM, that is random access memory. So, the term random access means that any memory location can be accessed directly without having to go through the other locations first. So, a RAM, it stores programs currently being executed, data that is currently being processed, and information required by CPU while working. Think about when you open Google Chrome, PowerPoint, or a game. These programs are loaded into RAM while they are running. RAM has some important characteristics. First, RAM is volatile. This means that when power is switched off, all data stored in RAM is lost. For example, if you're typing a document and the computer suddenly shuts down before saving, the unsaved work disappears because it was stored in RAM. Second, RAM is read and write memory. So CPU can both read data from RAM and write new data into RAM. Also, RAM provides fast access to data compared to secondary storage. Now, why RAM is needed? RAM acts as a working area for the CPU. So it temporarily stores running applications, active data, current instructions. So we can say that without RAM, the processor would have to access data directly from slower storage devices every time, making the computer extremely slow. Right? So if you look this table, use of RAM in devices and systems, I have mentioned all the exam focused pointers here. So laptop, desktops, they store open applications and operating system functions. Smartphones, they keep running apps, WhatsApp, YouTube in memory for multitasking. Game console loads textures, levels, and game logic in active gameplay. Printers, buffers print jobs sent by computers to allow continuous printing. In embedded systems, temporarily stores sensor readings, timer data, etc. So these are some points that you need to remember, that in a particular system or a device, what is the functionality of RAM. Okay. Now let's talk about ROM. What is ROM? ROM stands for read-only memory. Unlike RAM, ROM is non-volatile. This means that data remains stored even when power is switched off. And ROM, it stores permanent instructions required for starting and operating the computer. These instructions are commonly known as firmware. So basically, ROM is used to store firmware. ROM is used for storing important startup instructions, as I said. Examples: BIOS, basic input-output system. It checks hardware and starts the boot process. Permanent software stored inside devices, that is, firmware is stored, right? So if you need to look at use of ROM in devices and systems, In laptop, desktop, I have mentioned stores BIOS, smartphone contains bootloader, printer holds fixed settings and firmware, etc. Just have a look, because your past papers, they have some questions where in particular they have asked usage of or functions of RAM and ROM in particular scenarios or devices or systems. So you need to understand that whenever you talk about ROM, you're talking about permanent instructions to be saved. Whenever you're talking about RAM, you're talking about current instructions or data which is being saved, right? These are some comparison pointers of RAM and ROM. These key differences are based on the categories of type and volatility, functions and usage, access and modifiability, speed and capacity, real world examples. Just read them. You can pause the video and have a look. Now let's talk about types of RAM. First of all, we are going to talk about SRAM. SRAM stands for Static Random Access Memory. The word static means that data remains stored as long as power is applied. Unlike DRAM, that is dynamic RAM, SRAM does not require refreshing. SRAM, it is very fast, expensive, more reliable, lower storage density, and it does not require refresh cycles. And because of its high speed, SRAM is mainly used as cache memory. So SRAM, it uses flip-flop circuits to store each bit, right? So if you want to have a look at usages of SRAM in devices and why it is used, I have made this table. So CPU cache L1, L2, it is used. Embedded processors, SRAM is used. Networking equipments, SRAM is used. Now let's have a look at DRAM. Now DRAM stands for Dynamic Random Access Memory, and it stores data using capacitors. However, capacitors gradually lose their charge. Because of this, DRAM must be refreshed repeatedly to maintain stored data. This continuous refreshing gives DRAM its name, dynamic RAM, right? And if you talk about characteristics of dynamic RAM, that is DRAM, it is cheaper than SRAM, but it is also slower than SRAM, higher storage density, and it requires regular refreshing. Because it is less expensive and can store larger amount of data, DRAM is commonly used as main memory in computers, right? Now I'm just showing you comparison table of SRAM versus DRAM. Just have a look, because sometimes there are questions in paper to have a comparison of SRAM and DRAM. So this table will help you in answering all those questions. Also, sometimes they do ask questions where you have to justify why are you suggesting SRAM in place of DRAM, or why are you suggesting DRAM in place of SRAM in a particular given scenario. So SRAM should be used when speed and low latency are critical. And DRAM is used when high capacity at lower cost is needed. So remember these pointers whenever you have to justify your points, right? Now let's have a look at types of ROM. First of all, PROM. PROM stands for Programmable Read-Only Memory. It is supplied blank by the manufacturer, and a user can program it once. After programming, the contents cannot be changed. This is called a one-time programmable memory. You can't erase it, you can't modify it. Just once you can program it. So where it is used? It is basically used in devices with permanent setup, barcode readers, some IoT devices, right? safety critical hardware where updates are not allowed. Next comes EPROM. EPROM stands for Erasable Programmable Read-Only Memory. EPROM can be erased using ultraviolet light, UV light basically, and it can be reprogrammed after erasing. One limitation is that the chip often needs to be removed from the device before erasing. So you need to physically remove it from the circuit in order to erase that. And EEPROM is majorly used in older embedded systems, early firmware testing environments, devices where updates are rare but possible. We also have another type, which is EEPROM, which stands for Electrically Erasable Programmable Read-Only Memory. It can be erased and reprogrammed electrically. Unlike EEPROM, no ultraviolet light is required and it is more flexible and convenient to use. And you need not to remove it from the device physically in order to rewrite or erase or program it. It is slower than RAM, but it allows flexible updates and it is used in modern BIOS chips, in personal computers, microcontrollers, USB drives, SSDs. Okay. This is a comparison table between PROM, EEPROM, and EEPROM. And in order to answer questions that when a particular type of ROM should be used, uh, PROM should be used when data will never change. You only need to program it once. Use EEPROM where firmware updates or setting storage is needed. And EEPROM, it is less used today due to newer, more efficient EEPROM and flash technology. Now let's have a look at some past paper questions. First question is from May-June 2023. A networked closed circuit television system in a house uses sensors and cameras to detect the presence of a person. It then tracks the person and records a video of their movements. Data from CCTV cameras is transmitted to a central computer. Now, the computer has both ROM and RAM. Question is to describe the contents of ROM in the central computer, and it's of 2 marks. Now, we have already covered that what a ROM does, but always frame your answer by having a look at the question. So they have given a particular situation to you. So as you know, read-only memory, it stores, permanent instructions like startup instructions, firmware. So you need to modify your answer in order to write that, but relating to the situation which is given here. So you can write this as an answer that it stores the bootstrap program, stores the startup instructions for the CCTV system, or it stores the kernel of the operating system. Okay. Now, another question is, the central computer has dynamic RAM. Identify 2 advantages of using DRAM instead of static RAM. So this also we have covered up there. So you can write cost less per unit, higher storage density, simple design, uses fewer transistors, any 2 points you write and you'll get 2 marks. One more question. A computer has hardware and software. The hardware includes different types of memory. Complete the description of computer memory. Random access memory and read-only memory are both examples of which memory? One item that stores in RAM is, you need to write here. One item that stores in ROM is this. So I'm just showing this question. Pause the video, write the answer, and then I'll display the answer key. This is the answer key. So that's all for today. In today's video, we have covered random access memory, read-only memory, and types of both.